The Mars rover program is incredibly complex, especially from an engineering standpoint. I mean, the end result that you're trying to achieve is to get a suite of scientific instruments on the Martian surface on a mobile platform to drive around and do scientific experiments.
This MSL rover, called Curiosity, actually is the most complicated, most complex, and most capable system ever put on the surface of another planet. In fact, it might be the most complex interplanetary explorer that we've ever developed.
There are literally tens of thousands of parts that need to work together in perfect harmony in order to get through the launch operation, cruise to Mars, go through the entry, descent, and landing operation, and actually operate on Mars. And you need to be able to simulate that up front.
The challenges of building something like that with all the parts that are involved, all the discrete parts, all the interfaces, and all the testing, and the ability to maintain not just the documentation, but all the drawings, the test flows, the verification items, is a very complex task in itself.
On the rover design team, we used to joke like it was playing a giant game of three-dimensional Tetris. And if you're familiar with Tetris, you're presented with a whole bunch of pieces that are odd shapes, and they keep coming at you, and you need to adjust how they fit together before they reach the bottom.
This rover is almost a metric ton. So the biggest challenge was, how do you land something that weighs that much when you have a Martian atmosphere to deal with? That was the big challenge.
Mars has 3/8 the gravity of Earth, and there is no dial in a room that allows you to change the gravity on Earth. Therefore, the only way to simulate how something is going to behave on Mars is to do it in a virtual environment.
Our virtual testing was really used to do things where you would not have a physical prototype doing that.
This is by no means a sure thing. There's risk involved. You can't test these systems end to end. There's also the risk of Mars itself. Mars usually wins this battle. Our success rate globally is well below 50%. However, we feel confident that we've done everything, and if everything goes the way we've designed it, and we've planned it, and we've built it, and tested it, and the team will be cheering.